Hey everyone, welcome back. I hope you're all doing well. In this video, we'll walk through a few examples of the earned value management method. Specifically, we'll apply EVM to assess project schedule and cost status, predict the final project cost, and create an EVM chart to help evaluate overall project performance. Let's get started with example 1. The total budget for the project is 5,000 man-hours, and by the original completion date, the project is 96% complete, with 14,700 man-hours used so far. We need to determine the project status at this point in time. First, let's calculate the planned value and earned value. Planned value, PV, or budgeted cost of work scheduled, BCWS, is essentially the total budget for the project, which is 5,000 man-hours. Since we're looking at the original completion date, so the entire project was planned to be completed by this date, thus the PV at this point is 5,000 man-hours. Earned value, EV, or budgeted cost of work performed, BCWP, is the amount of work we've actually completed. 96% multiplied by the total budget, 5,000 man-hours, equals 4,800 man-hours. This value represents how much work was actually accomplished compared to the planned amount. Next, actual cost, AC, or actual cost of work performed, ACWP, is the actual amount of work done, measured by the hours spent. In this case, 47,700 man-hours were used, as given. Now, let's analyze the project's performance. Schedule variance, SV, tells us if we're ahead or behind schedule. We calculate this by subtracting the planned value, PV, from the earned value, EV. In this case, 4,800 man-hours, EV, minus 5,000 man-hours, PV gives us negative 200 man-hours. This negative value means the project is behind schedule by 200 man-hours, which is unfavorable. Next, cost variance, CV, tells us if we're over or under budget. We calculate this by subtracting the actual cost, AC, from the earned value, EV. Here, 4,800 man-hours, EV, minus 4,700 man-hours, AC, gives us 100 man-hours. This positive value means the project is under budget by 100 man-hours, which is favorable. Instead of using SV and CV to assess schedule and cost status, we can use SPI and CPI measures, which will give us the same results. The Schedule Performance Index, SPI, shows how we performed in terms of time. We calculate this by dividing earned value, EV, by planned value, PV. In this case, 4,800 man-hours, EV, divided by 5,000 man-hours, PV, gives us 0.96. Since the SPI is less than 1, it's unfavorable, indicating that we're behind schedule. Finally, the Cost Performance Index, CPI, shows how efficiently we're using our budget. We calculate this by dividing earned value, EV, by actual cost, AC. In this case, 4,800 man-hours, EV, divided by 4,700 man-hours, AC, gives us 1.02. Since the CPI is greater than 1, this is favorable, meaning we're getting more value for less money. To sum it up, the project is behind schedule by 200 man-hours, but is under budget by 100 man-hours. The schedule performance is unfavorable, but the cost performance is favorable. We need to catch up on the schedule while continuing to manage costs effectively. All right, let's walk through example 2. This one's a bit more complex than the first. We'll be using the updated project schedule from the previous lesson on schedule updating. This is the updated schedule, reflecting the current status as of day 18. The schedule includes both the baseline, shown in black bars, and the updated schedule, shown in blue bars. Some activities don't perfectly align with the grid lines, but the start and finish dates are marked to make things clearer. To make it easier to solve this problem, we'll organize the information in a table. In the first column, we list all the activities. The second column shows the baseline cost for each activity, and the sum of this gives us the total budget of 242 man-days. The third column shows the actual cost paid up to now, which totals 45 man-days. In the next two columns, we calculate the as-planned percentage complete, using the baseline schedule and the actual percentage complete based on the updated schedule. The sixth column will show the planned value, PV, which is calculated from the as-planned percentage complete, and the seventh column will show the earned value, EV, which is calculated from the actual percentage complete. Once we have all the necessary data, we'll assess the project's status by answering questions 1 through 6 listed on the left. Let's start with the as-planned percentage complete, column 4. To calculate this, we must use the baseline schedule, the black bars. Now, this tells us how much work was supposed to be completed by day 18. For activity A and activity B, their baseline bars are fully to the left of day 18, so they're 100% complete, as planned. For activity C, the baseline bar is halfway through. To calculate its as-planned percentage, we subtract the start date, which is day 10, from the status date, which is day 18, then divide that by the total duration of the activity. We get 44.5%. Next, for activity D, the baseline bar is fully to the right of day 18, so it has 0% complete scheduled by the status date. For activity E, the baseline bar goes from day 16 to day 33, crossing the status date, day 18. To find the as-planned percentage, we subtract the start date, day 16, from the status date, day 18, and then divide by the total duration, which is 33 minus 16. This gives us 11.8%. For activity F, we do something similar. We subtract the start date of day 16 from the status date of day 18, then divide by the total duration, which is 37 minus 16. This gives us 9.5%. For the remaining activities, the baseline bars are scheduled to start after day 18, so they're all 0% complete, as planned. Now, let's move on to the actual percentage complete. Using the updated schedule, the blue bars. This calculation is similar to the as-planned percentage, but now we use the blue bars. For activity A and activity B, their blue bars are still to the left of the status date, so they're 100% complete. For activity C, the start date is after day 18, so it's 0% complete. The same goes for activity D. For activity E, it is on schedule, so the actual percentage complete is the same as the as-planned percentage complete, which is 11.8%. For activity F, which started earlier than originally planned, we calculate the percentage complete by subtracting the actual start date, day 13, from the status date, day 18. Then we divide that by the total baseline duration, which is 37 minus 16. This gives us 23.8% complete. Keep in mind, this method assumes the daily production rate hasn't changed. In real-world scenarios, actual percent complete should be measured using the methods we discussed in the previous video. The remaining activities start after day 18, so they are all 0% complete. Now that we have both the as-planned and actual percentages complete, we'll add those results to the table, the baseline percent complete in column 4 and the actual percent complete in column 5. With this data, we can now calculate the planned value, or PV, and the earned value, or EV. To calculate PV, we multiply the total budget for each activity, column 2, by the A as planned percentage complete, column 4. For activity A, since it's 100% complete, PV is 100% times 20, which gives us 20 man days. For activity B, PV is 100% times 10, which gives us 10 man days. For activity C, PV is 44.5% times 36, which gives us 16 man days. For activity D, PV is 0% times 20, which gives us 0 man days. For activity E, PV is 11.8% times 34, which gives us 4 man days. For activity F, PV is 9.5% times 42, which gives us 4 man days. For all the other activities, the planned value is 0, since their baseline percent complete is also 0. Adding up all the PVs gives us the total planned value for the project, which is 54 man days. Next, let's calculate the earned value, EV. This is the total budget for each activity, column 2, multiplied by the actual percentage complete, column 5. For activity A, EV is 100% times 20, which gives us 20 man days. For activity B, EV is 100% times 10, which gives us 10 man days. For activity C, EV is 0% times 30, which gives us 0 man days. For activity D, EV is 0% times 25, which gives us 0 man days. For activity E, EV is 11.8% times 34, which gives us 4 man days. For activity F, EV is 23.8% times 42, which gives us 10 man days. For all other activities, their EV is 0 as they have not started yet. Adding up all the EVs gives us the total earned value for the project, which is 44 man days. By comparing the earned value and planned value, we can easily spot which activities haven't started yet, like activity C, activity D, and others, which all have 0 EV. If the earned value is less than the planned value, it means the activity is behind schedule. For example, activity C is behind because its EV is lower than its PV. If the earned value is greater than the planned value, like in activity F, it means the activity is ahead of schedule. Activities E is on track because the PV and EV are the same. Now, we'll answer these 6 questions to get a full picture of both schedule and cost performance. First up, question 1. We calculate the total planned value, or PV, which is basically the sum of column 6, that's 54 man days. That's basically how much work we plan to have done by day 18. Question 2. Now for the earned value, or EV, that's 44 man days, which is the sum of column 7. This tells us how much work we've actually completed. Question 3. Let's find the schedule variance, or SV. We take EV minus PV, 44 minus 54, which gives us minus 10. That negative number means we're behind schedule. Question 4. Now we calculate the Schedule Performance Index, or SPI. That's EV divided by PV, 44 divided by 54, which comes out to about 0.81. Since that's less than 1, again, we're behind schedule. Question 5. Let's check out the cost variance, or CV. That's EV minus AC. In this case, 44 minus 45, which equals minus 1. So we spent a bit more than we should have. We're over budget. And finally, question 6. We calculate the cost performance index, or CPI. That's EV divided by AC, 44 divided by 45, which gives us 0.98. Still under 1, so again, a small cost overrun. To sum it up, we're a little behind schedule and slightly over budget. All right, let's move on to example 3, which continues from the previous one. We'll start by looking at the key results we got earlier. Our earned value, EV, is 44 man-days. The actual cost, AC, is 45 man-days. And our cost performance index, CPI, is 0.98. Now, let's work through some additional calculations. First, let's figure out the budget at completion, BAC. This is the total budget for the entire project. And in this case, it's 242 man-days. So that's pretty straightforward. BAC equals 242 man-days. Next up, we need to calculate the estimate to complete, ETC. This tells us how much needed to finish the project. We're going to look at 2 different scenarios here. In the first scenario, we assume that the future performance of the project is going to continue at the same rate as it was planned to be. This is where we use a CPI of 1 for the remaining work, meaning we expect performance to be exactly as planned moving forward. To calculate the ETC in this case, we take the budget at completion, BAC, subtract the earned value, EV, and divide the result by the CPI of the remaining work. So we do 242 minus 44 divided by 1, which gives us 198 man-days as the estimate to complete. In the second scenario, we assume that future performance will continue at the same rate as past performance. Here, we use the actual CPI of the completed work we calculated earlier, which is 0.98. So to calculate the ETC in this case, we do 242 minus 44 divided by 0.98, and that gives us 202 man-days as the estimate to complete. Now that we have the ETC, let's move on to the estimate at completion, EAC. This tells us how much the total project is going to cost by the time it's finished. We calculate it by adding the actual cost, AC, to the estimate to complete, ETC. For the second scenario, where future performance is at the same rate as past performance, we add 45 man-days, the actual cost, to 202 man-days, the ETC, which gives us a total of 247 man-days for the estimate at completion. Finally, let's calculate the cost variance at completion, CVAC. This tells us whether we're going to be under or over budget by the time the project finishes. To calculate it, we subtract the estimate at completion, EAC, from the budget at completion, BAC. So we do 242 minus 247, which gives us a result of minus 5 man-days, meaning the project is projected to be 5 man-days over budget. And that's it. That's how we forecast the project's budget at completion using the EVM method. Now, let's move on to the final example in this video. In this scenario, you are given a table that outlines the baseline schedule and cost for a specific project. 3 months after the project began, the superintendent informs you that activities A, B, C, and E have been completed, along with half of activity F. The total cost incurred so far is $700. Your task is to evaluate the current status of the project using the Earned Value Management, EVM method. To do this, you first need to develop an EVM chart that shows the planned value, or PV, across the entire project timeline. Once the PV curve is established, you will then plot the current earned value, or EV, on the chart based on the amount of work completed to date. With this information, you will assess the project's status by determining whether it is over or under budget and whether it is ahead of or behind schedule. All right, here's the baseline schedule. We've got project activities labeled from A to J, each with its own budgeted cost. The total project duration is 6 months, and every activity is planned to be completed within a specific time frame according to this baseline schedule. Our goal is to calculate the cumulative planned value, PV, at the end of each month, and then use this to construct the PV curve. Let's begin with month 1. According to the schedule, activity A is supposed to be fully completed in this first month. Since its budget is $100, the total PV at the end of month 1 is simply $100. Moving to month 2, we add the value of all work that is scheduled to be completed by then. Activities B and C are both set to be 100% complete in month 2. B is budgeted at $200 and C at $50. Adding that to the $100 from month 1, we get a cumulative PV of $350 by the end of month 2. In month 3, 3 more activities, D, E, and F, are planned for completion. Their respective budgets are $100, $50, and $150. Adding those together gives us $300. When we add that to the previous PV of $350, the total PV at the end of month 3 becomes $650. For month 4, we're scheduled to complete activities G and H. G has a planned budget of $300 and H has $100. That's another $400 added to our cumulative value. So by the end of month 4, the PV becomes $1,050. In month 5, we add activity I, which contributes another $50. That brings the total PV up to $1,100 by the end of month 5. Finally, in month 6, the last activity, J, is scheduled for completion with a budget of $500. Adding that to our existing total gives us the final cumulative PV of $1,600 by the end of the project. When we plot these PV numbers on the chart, we get the PV curve. It starts at 0 when the project begins and gradually goes up, reaching $1,600 by the end of the project schedule. All right, let's move on to the next step, which is figuring out the earned value, or EV, after 3 months. That's our status date. To do that, we need to use the update schedule, which tells us what's been done so far and how much of each activity has been completed. Based on what's given, activities A, B, C, and E are all fully completed. Activity F is only halfway done. The rest haven't started yet. We can show this progress on the bar chart. Just shade in the bars to show how much of each activity is finished. That shaded portion basically tells us the percent complete. Now, let's calculate the earned value at the end of each month. By the end of month 1, only activity A is complete. Since it's 100% done, we earn its full budget, which is $100. In month 2, both B and C get completed. B is worth $200 and C is worth $50. Add that to the $100 from month 1, and the total earned value by the end of month 2 is $350. In month 3, activity E is fully completed and half of F is done. So from E, we earn $50, and from F, which is worth $150 in total, we earn half, so $75. Add that to the $350 we already had, and we get a total earned value of $475 by the end of month 3. Note that activity D was planned for month 3, but since it hasn't started yet, we don't get any value from it. Let's plot the earned value at the end of month 3, which is $475. Comparing it to the planned value curve, we see it's below, meaning the project is behind schedule, or we've earned less than what we planned. Now, for the cost status, the actual cost is $700. Comparing this to the earned value, the actual cost is above, meaning we're over budget. We're spending more than we've earned. In short, our project is behind schedule and over budget. We need to address both the timing and cost issues to get back on track. All right, that's it for this video, where we walked through a few examples of how to use the EVM method to assess the project status, as well as forecasting the final project cost. Thanks for watching, and we'll see you in the next video. Goodbye.